So you really want to think of inverse functions as the reverse of that function. So it basically undoes all the operations that we had already done on a function. So let's take a look back at the examples we did before. So if f of x is 2x, well, what am I doing to x? I'm multiplying it by 2. Then its inverse has to do the opposite of multiplication, which would be division. The other one we found to be inverses, well, if I look here, what did I do to x? Well, I added 5 to it, and I took the cube root of it, so what I need to do to undo that is to subtract 5 and cube it. So the inverse of a function undoes the operations we already had done on x. Well, how is it that you find the inverse of a function? Well, the very first thing you want to do is replace your f of x with y. Then you're going to swap your x and your y in your function, and then solve this new equation for y. Once you're solved for y, you replace your y with f inverse of x, and again this is said f inverse of x, it's not f to the negative 1, and you're all done. So let's look at example 10. Example 10 asks us to find the inverse of the one-to-one function and graph both of them on the same axis. So the first thing I need to do, step 1 says replace my f of x with y. So I'm going to rewrite this as y is equal to 2x minus 4. Then I'm told to swap my x and y. So I rewrite, instead of y here, x, and then equals 2, instead of x, I change that to my y minus 4. So all I've done is swap the x in the y's position. Now I need to solve this new equation down here for y. Well, in order to isolate y, I start by adding 4 to both sides. So I get that x plus 4 is equal to 2y. If I divide everything by 2, I end up with 1/2 x plus 2 is equal to y. Once I'm solved, step 4 says replace y with that f inverse of x. So I write f inverse of x is equal to 1/2 x plus 2. That is the inverse of f of x is equal to 2x minus 4. Then it also asks us to graph both of these on the axis. Well, let's graph both of them. Well, this top one, my f of x, that is just a line. Its slope is 2 over 1. Its y-intercept is negative 4. So let's start by graphing that. So there's my y-intercept, and I go up 2 over 1. Well, let's graph the inverse function. This is also a line. Its slope is 1/2, and its y-intercept is 2. So I go to my y-intercept at 2, and then I go up 1 over 2. That's the graph of f inverse. Right, well, let's take a look at some of the properties of inverses. The properties of inverses are as follows. If I compose f with its inverse, it equals x, or the inverse with f of x, it equals x. Well, that makes sense to us because we know that in order for two functions to be inverses, their compositions have to give you x. Second thing is that f of x and f inverse of x are reflections of each other with respect to the line y equal x. Well, let's go back up and look at the graph that we just drew. Well, the line y equal x would be this line right here. Line that cuts at a 45-degree angle. Well, can I fold the graph over at that line and have my graphs of f and f inverse line up? Yes, if you look, they look exactly alike on other sides of that line. So they are symmetric with respect to the line y equals x. Also, the domain of f of x is the range of f inverse of x, and the range of f of x is the domain of f inverse of x. The reason for this is, remember, we swap the x and the y to find the inverse. So it makes sense that the x's for my f of x are the y's for my inverse, and that the y's for my f of x are the x's for my inverse. Alright, well let's look at the last two examples where we're doing the same thing, finding the inverse and graphing it. Example 3, first thing I need to do is replace f of x with y. Next, I need to swap the x and the y. Now let's solve for y. So I need to undo my cube root. I cube both sides. I get x cubed is equal to cube and the cube root cancel, y plus 1. Solving for y, I get x cubed minus 1 is equal to y. Now I need to replace my y with f inverse of x. So f inverse of x is equal to x cubed minus 1. Now let's graph both of them. Start by graphing f of x. Well, what is this? Well, its basic shape is the cube root function. It has a horizontal shift of left 1. It does not have a vertical shift. And its compression stretch is the number in front out here, and that's going to be 1. So let's draw that. So horizontal shift of 1, vertical shift of 0 puts us right here. Compression stretch is 1, so I go up 1, right 1, down 1, left 1, and then I go ahead and draw that function. So this is the graph of f. Well, let's graph f inverse of x. Well, f inverse of x, remember its basic shape is the cube function. It does not have a horizontal shift. Its vertical shift is down 1, and its compression stretch, the number out in front, is equal to 1. So my vertical shift of down 1 is here. Compression stretch says up 1, right 1, down 1, left 1. And I draw this function, and this is f inverse of x. If I were to draw the line y equal x, and you're not required to do this, but if you were to draw this line y equal x, doesn't it look like those graphs are reflections about that line? All right, let's look at example 12. Example 12 is f of x is equal to the square root of x minus 2. First thing I need to do is replace my f of x with y. Now I need to swap my x and my y. Now we need to solve for y. Well, I have to undo a square root, so let's square both sides. So I end up with x squared is equal to the square and the square root cancel, y minus 2. Solving for y, I get x squared plus 2 is equal to y. Replace y with f inverse, so f inverse of x is equal to x squared plus 2. Let's graph both of these. Start with f of x. Well, the basic shape for that is half of that sideways parabola. Its horizontal shift is right 2. It does not have a vertical shift, and the compression stretch is equal to 1. So right 2, and this one was up 1 over 1. So this is the graph of f. Well, let's graph f inverse of x. Well, f inverse of x, its basic shape is a parabola. Its horizontal shift does not have one. Vertical shift is up 2. And its compression stretch, well, the number out in front is 1. So I go up 2, up 1, left 1, and up 1, right 1. So this is the graph of f. Now, please be careful. I am going to be erasing half of this. So if you're writing in pen, make sure that you end up crossing out what we don't need. Now, I'm going to draw that line y equal x that we've been drawing before. If I fold these up, will they match? No, they won't. This graph has an extra piece. Okay, well, let's look at something else. If I were to draw a horizontal line here, would I pass the horizontal line test? No. Well, that's not a one-to-one function. It shouldn't have an inverse. Well, we need to restrict the domain of the inverse function here. The reason for that, recall, is that we said earlier that the domain of f inverse is the range of f, and that the range of the inverse is the domain of f. So let's take a look at this red function f, and let's find its domain and range. Well, the domain of f, if I look here, well, the furthest left I go is 2, and then I'm off to positive infinity. Well, what about the range of f? The range of f, the smallest I am is 0 on my y-axis, then I'm going up to positive infinity. Well, that means that the range of f inverse has to be from 2 to positive infinity, and that the domain of f inverse has to be from 0 to positive infinity. Let's start with the range. Is the range of this so far 2 to positive infinity? Yes, that's great. But the domain, the x's, have to only be from 0 to infinity. Well, if I look here, am I 0 to infinity? No, currently I'm all real numbers, so I must take off this left portion of the graph and just make myself have a domain of 0 to infinity. Now does it look like my lines are reflections of each other about the line y equal x? Yes, they do. So please note, if you find the inverse of a square root function, so that was an f of x equals the square root of x, you must, very important, restrict the domain of the inverse. And that only happens when you're finding the inverse of the square root of x. That's it for inverse functions.